Hello everybody. In this video, we are going to see shortest job first scheduling algorithm. As part of this, I'm going to use this data, which is having 5 processes, and it is having details about the arrival time, and it is having burst time, priority details, and the remaining time is there. The column is empty. I'm not going to use that one. So our objective is to find average waiting time. So we're going to calculate average waiting time um, for every processes, so all the processes together. So what is the average waiting time? So we just have to find waiting time for every process, and we have to average that out. So what is the waiting time? Waiting time is a total time a process spent in the ready queue is called waiting time. And what is the turnaround time? It's waiting time plus burst time. So that is turnaround time. And what is burst time? Burst time is time a process needs in the CPU. That means we can say how long a process needs the service of CPU, or we can say how much CPU time is needed by a process. So this is called burst time. Okay, so we are given all these, and the priorities of processes are also given. In our case, the lowest priority means lowest number means highest priority. By saying this, 1 is the highest priority, and which is corresponding to process 5, and 5 out of all these which is having the highest number and is the lowest priority, which is for P4. And arrival time is time at which a process comes into the ready queue. Okay, so let us start this algorithm, shortest job first algorithm. Basically this is non-preemptive. Okay, non-preemptive means once a process gets the processor, it will not leave the processor till it finishes. So that is called non-preemptive type of scheduling. Okay, so shortest job first, which is say SJF. It's not SJT, SJF. Okay, SJF is usually non-preemptive in nature. So let us put the Gantt chart and we find the average waiting time for this. So let us start this process. So here we have seen various arrival times. So arrival time means at what time a process comes into the ready queue, and the scheduler will always select a process from the ready queue only to the CPU to run in the CPU. So that means at time 0 only P2 is visible to the scheduler. That means there is no other go. It has to select only the P2. P2's burst time is 4. So in this case, it is 0 is the arrival time, and all these are coming after that. So at this first scenario, you see only P2 process. So there is no algorithm applied. You just select the P2 and P2 will run. So I'll just put P2. P2 will run from 0 to 4 because it is non-preemptive. It runs fully. At 4 time unit, these two will come. You see, at 4 time unit, these two will come, and it is say waiting. Okay, these two processes, which is P3 and P4, comes and it is waiting because at the time unit 4, these two arrived, but P1 will arrive at 5 only. P5 is arriving at 8 only. So out of these two, which one comes first? P4 comes at the time unit 1. Okay, so out of this 2 now available, we should select which is having the shortest burst time. So which is having the shortest burst time? P2 are available. Okay, at time unit 4, P3 is also available, P4 is also available. So which one I should select? I should select the shortest job. So which is having shortest? Which is the shortest job? P3, because P3's burst time is 1. 1 is less than 7. So I'll select P3. So P3 runs for 1 burst time. So it will run from 4 to 5. It finishes at 5. So okay. So I'll just change it to green whenever it is finished. So this is finished, and P2 is finished, and P3 is finished. Now at 5, which is there, at 5 I got this P1 also into the fray. It also comes into the fray, but 8 didn't come. So P1's burst time is 5, P4's burst time is 7. So which one I should select? I should select P1. P1 is selected because its burst time is lesser than P4's burst time. So how long it will run? 5 to 10 time units will run. So at that 10th time unit, this will also come. So P1 finishes. I'll change this to green, and P5 is also came into the ready queue now. Both are there. See the burst times. Burst time is 5 here. So P5 will be given a chance. So P5 will run from 10 to burst time is 5. So 10 to 15 it will run. Okay. So then P5 finishes. So change it. P4 is only remaining. So I'll just allot the processor to P4. P4 will run from 15 to 22 because burst time is 7. Okay. Now this is also finished. All are finished. Okay. So we have just calculated the start and end times of all the processes, and the Gantt chart is ready. Once the Gantt chart is ready, I can just find the waiting time. So if you want to find the waiting time for P1, I just have to find what is the start time of the P1. P1 starts at 5. When P1 comes into the queue, 5. So that means 0 is the waiting time. Okay. And what is the waiting time of P2? P2 got the processor at 0. Arrival time is 0. 0 minus 0, 0. Okay. P3, when it got the CPU, time is 4 at that time. Okay, at 4th time unit it got the CPU. P3's arrival time is 2. So how long it was waiting in the ready queue? 4 minus 2, 2. P4, P4's arrival time is 1, but P4 got the CPU at 15. 15 minus 1 is 14 is the waiting time. What is P5's waiting time? P5 got the CPU at 10. P5's arrival time is 8. So 10 minus 8 is 2. So for 2 units it was waiting in the ready queue. So this is the total. Okay. So if you want to find the average, okay, if you want to find the average of this, so it is 3.6. So let us see what is the turnaround time for everything. Turnaround time is nothing but waiting time plus burst time. Waiting time is 0 for P1. What's the turnaround time is 5. So 0 plus 5, 5. P2's burst time is 4. 0 plus 4, 4. P3's burst time is 1. Waiting time is 2. 2 plus 1, 3. P4's burst time is 7. Waiting time is 14, so it is 21 totally. P5's burst time is 5 and waiting time is 2, so turnaround time is 7. Okay, so that's it. So this is how you have to perform a shortest job first. In case of tie, say for example, there are 2 processes or more than 2 processes having same shortest burst time. So which one I should select? Then you can break the tie by seeing the arrival time, or you can break the time by priority, or in some other combination. That's all depends upon the policy to break the tie, but this is how basically it works. Shortest job first is usually it is non-preemptive in nature. That's one thing you have to understand. Non-preemption here, once the process gets the processor, it will not leave it till it finishes. Okay. Thank you for listening.